everyone. Today will be not too long lesson because I don't have much time, and on top of that, I think live coding would be quite hard because I have a semi-broken mouse. So I ordered a new one, and it's supposed to arrive either on Friday or on Monday. So next week it'll be better, but for this week it's pretty bad and therefore some delays. But I think I managed to make a decent lesson. I think this is a better lesson than the previous one, and this will give you some insight on second part of LINQ about more complex queries, about more complex LINQ statements. Maybe I'll raise it a bit. Is my voice any better? I raised the volume a bit. I can raise it a bit more. I'm afraid that mic still low. Okay. Raised it like 20% more, so it should be better. Okay. So the purpose of this lesson, if in previous lesson of LINQ we learned how to filter stuff, in this lesson we'll learn how to transform stuff, how to map it, and how to scratch the stuff, nest it inside some complex data structure. Scratch it and get exactly what you want. Sometimes even without the need of having a special data class for that purpose. So we'll learn how to do data transformations with LINQ, and also we'll try to delve into Curie syntax. So let's get to it. So the LINQ methods that we'll be learning today is select. We'll learn about anonymous object. We'll learn about selecting to anonymous object, selecting many, join, group by, group join. Then we will have a look at Curie syntax, how is it different. We'll discuss the semantics and when to use Curie syntax and when not. And some pitfalls, but I ran out of time and pitfalls will be shown in live coding part. So method syntax. Imagine you have a car, right? A list of cars, and a car is a data structure. It has a name, a model, it has owner, but all you care is the model. So you want to extract a model of a car from the car and select a list of models from a list of cars. And the answer how you do this is by using a select. So select is a mapping mechanism, and it maps a collection for A into a collection for B. So inside the select statement, you do the lambda, which is a selector function. So that selector function would look like that it takes a car and it returns whatever you want. And it returns whatever you want, and LINQ will understand what is the return type. And since model is a string, it will understand that after selecting from every car in collection, after every car model in collection from cars, the end result will be not cars, but an enumerable of strings, because model is a string. Oh god, my mouse. You can select new objects with select statement, but let's talk about anonymous object first. So before we learned that we can have anonymous functions. Anonymous functions like functions that don't need a name. For example, your lambda in LINQ are all anonymous functions because you didn't write a function for the predicate or for the func that you pass in LINQ. So we can do the same with creating new objects. We don't have to create a class for creating a new object. And this is called anonymous object because it doesn't have a class name for which we create that object. And in this context, var means no type. It means that it's anonymous type. Equivalently, I could just say object and say anonymous is of type object. That would work as well. Now, is this like dynamic? And the answer is no, it's not like dynamic. It's not like dynamic because you still have IntelliSense, and locally in the local scope that this is created, you can still work with it just fine. For example, you see I have created anonymous object with name Kaizenal, and I can still access name of that anonymous object. And this might seem that there is no IntelliSense, but in fact there is, and I'll demonstrate it. So simple anonymous object. Sometimes so this is quite rare. It might happen, but it's quite rare. And this case is even more rare. And sometimes we need to consume an anonymous object outside the scope that it was created in. So outside the method it was created in. For example, in function foo_anon, you can see we created this anonymous object and then we returned it as type object. And here you can see that we can still consume it just fine as an object. If we don't need to treat the type explicitly, if we don't get anything from it, if for example we just want to print the whole object, we don't need to know what kind of object that is. It's treated polymorphically, generalized, and not specified. So we don't need to specify what type it was. However, if we still want to access its properties, then, like Joe Stryker said, we can use dynamic data type. And dynamic data type basically turns off all IntelliSense and it casts a type to whatever type we need. And we don't need to care how it works. It just does. And if it doesn't, it will give you an exception, like if it's impossible to convert it to what you want. So with dynamic, you can have random invalid code and it will compile. But when you hit it, it will throw an exception. Here, if instead of var I wrote dynamic, I could in my write line use anonym dot name. That would work, but now I cannot because it's an object. Avoid dynamic. It's your last resort, and I really do not recommend using it at all. Just when you're cornered, when there's no other option, only then it's okay to use it. But avoid it and search for better options. So we can't select new objects with a select statement. So we can create new objects using a select statement, a list, or enumerable to be precise. And we can select anonymous objects as well. So here we have information about a person, his name, his birthday, his age, his weight, his height. But what if we want to make some statistics, like who is born at what birthday, at what day, for example? So all we need is those two things. So we can scratch those out in an anonymous object, for example. So just a name and a birthday out of a person we select. and print like this, and the result is as you see. So an interesting thing about anonymous object is that it automatically implements the string. So if there is no way you can add the functionality to print itself from an object, and it has to have that method to string. Every object has the method to string. So the default implementation, the only implementation of the string of an anonymous object is printing it like you see here in the same pattern, where you have those brackets, curly braces, and name equals, and property equals value, comma, property equals another value. So that's the pattern how anonymous objects gets printed, and therefore it's useful for that purpose, for just printing it, for debugging, for saving it to a file or similar. Select many is actually a very nice LINQ method, and it simply means flatten a collection. So imagine if you have a collection in which there is another collection. So here in this example, we have two pictures. So imagine it's two owners of cars. So we have one owner and another. And one owner has 10 cars and another owner has 10 cars, for example. But all we want is a total list of cars. So in other words, we want to flatten a list of cars to have all cars that is belonging to those two people. And how do we get all cars? The answer is using select many. So it flattens a collection that contains another collection. So here we have car owners, and car owners have cars. So in select many, I need to provide how do I select the flattened collection. And I simply say that my select many will select cars of car owner. And that's the new collection. Like those cars will go to the new collection. We'll make a union with cars from another collection of another car owner. So the end result is that we have 20 cars. If first had 10 and second had 10, in the end we'll have 20 cars. Yes, if we use just select the problem would remain. We would need to do something to flatten it still. Therefore, there is this distinction between select and select many. Now, sometimes we have different contexts, but we need to join those contexts and work with both contexts at the same time. For example, if we have cars and people, maybe we want to create owners of cars. So basically a list of people with cars. So join does just that. It merges two contexts, and then we can select from those contexts something that we want in a grouped way. Join basically allows us to make pairs of joined contexts. So if we have context A and context B, for every A and B, there will be C that contains both A and B. So for example, if we have a person and a car, from a person we can select a name, and from a car we can select a model. And so in our new object we'll have every person who has with its belonging car model. Aurora said that zip exists in Python, but compare the naming and the fluidity of C# and Python. Zip for me means nothing, and actually it means the opposite, that we compress something. But join, it really means what it says, that we join two contexts. Oh, come on. Really? I didn't know that LINQ has zip, but okay. So here you can see how we join people to cars. So when the key point here is when you do a join, you need to provide the inner key and the outer key. So you need to say what key will be linked to what other key. So you need to link people to cars somehow. Therefore, you need to expose a key of a person and how car links the person. So person has ID and a car has owner ID, and owner ID and ID matching will create a pair of name and car model. So basically, what person owns what car model. Ah, I see, Joshmont. It's a good example. So Joshmont said that zip in LINQ means that it joins two collections into one, just like you would connect two different pieces of fabric with a zip. Well, similar pieces of fabric. I have not used zip myself, so I cannot give more comments on it. But I think in a wiki I'm now interested and we'll try to add it. Okay. Now group by. So group by is kind of similar to join, except that you don't have to join another context. You basically group by with the same context. So something of the same context. So basically, if we have cars and cars have owner ID, we can then say how many cars, for example, or what cars belong to what owner ID. Like group by creates a grouping. So something very similar to a dictionary where you have a ID, some sort of an ID, some sort of a key, and the value will be what belongs to that key. Okay, so yes, I see that the links for some reason are disabled. Sorry guys. I'm not sure if I can change settings somehow fast. Let me click. Don't see anything immediate. Moderation rules, maybe? Block hyperlinks off. I turned it off now. You can send the link again. It should display. Oh god, how do I? You can send the links again. Oh, come on. It says it unblocked. Okay, just send it in, yeah, on Discord, it's fine. I'll include it in the slides after the lesson. So group by is very similar to join, except that in join you need another context, and with group by you use the same context. So you group elements of the same context and you basically create pairs. Pairs where first thing in a pair is a key, and another thing is what belongs to that key, some collection of values. So here you can see basically this means that I say what cars belong to what owner ID. And here I say, on top of those mappings for car, for owner ID belonging cars, here I stitch together also personal information. So person and cars. So I can build now car owner fully by selecting a person by owner ID. And since I have a grouping of cars by owner ID, I can just add the cars. Of that grouping. So yeah. Okay. And here in the picture, you see basically the result would be it would be that we have a flat list of cars, but since I did a join afterwards, I stitch extra things. So in the end, we have a person with its multiple cars and many people with their multiple cars. And however, that's not very practical, and normally we want to have a proper list of people right away. And look at the difference of this. There is group join method, and here we see we did group by and then we joined. But since that is a common case, we can simply group join right away. And it's very literal as it does both things. It basically means that to people, we join cars. So now every person will have cars linked to them. Not one car to one person, but many cars to one person and to many people like that. Yeah, exactly. Group join, group by and group join are grouping stuff. So from flat structure, they group it. They create relations and collections, one-to-many relations. Though join is supposed to be something that creates pairs, and group by is something that creates um, 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 basically a group from its own context. So maybe I will fix this to create a group from its own context. Mouse. Oh, my mouse. Okay. And yeah, that's pretty much all the common LINQ that you'll be using. Personally, I haven't used any other LINQ than this, and it's plenty. And surprise, surprise, but in C# you have many ways to do the same thing, and there is in fact a mirrored version of the same LINQ that you can write with Curie syntax. And Curie syntax essentially is just a syntactic sugar on top of what you have LINQ. It's still based on those extension methods on top of the enumerable. So when you write Curie syntax based LINQ, it's kind of, the start is very similar to for each loop. So it's very similar. Instead of from, in a for each loop you have bar, and then person in people is the same as you would write in a for each loop. So the structure is from element in collection, and then you can do whatever you want. For example, select new people and so on, right? In live coding, I'll delve more into Curie syntax and show more examples. So when to Curie syntax? It's simply much more convenient at some point, at some points, and it's especially convenient using uh, curing stuff. It's not so convenient when you make data transformations, but when you query stuff, when you filter stuff, when you select data, maybe group data, but not transform existed data, it's pretty nice. It's pretty neat and good. I wouldn't use Curie syntax for extremely complex queries, but I would use it for something that recalls SQL. I'm not going to talk about SQL yet, but Curie syntax is supposed to be heavily inspired by it. And therefore, when you're querying data from a database, it's very convenient to apply this syntax because it's very similar. And here you can see an example of group join. So how does this read? So we say from person and people join car and cars. And the key point here is that on every thing that you join or select from, you need to continue the pattern of element in collection, always the same pattern is repeated all over again. And what I really dislike about Curie syntax, because it makes the code, writing code significantly more hard in terms of it gives you very little tips of what goes wrong. For example, here you can see that we join basically join people with cars. And I say that person ID equals car owner ID, right? Equals, if you write equality sign instead of equals, it will not work, nor it will say what's wrong. So that bit is annoying. Another bit, if you swap places car and person, it won't work. It expects in this place to be a person. And in fact, it won't autocomplete or suggest that there should be a person. If you say something, if you write something, it will actually autocomplete from people. And it's quite annoying. You need to understand what you're writing and be more proficient in order to use Curie syntax. So I consider Curie syntax to be slightly more difficult, especially if you're not proficient with SQL. But it's useful. When you get the hang of it, it's very useful. And it's way more simple when you apply it to complex joins and complex queries. Complex queries in a sense that you stitch two different contexts into one or multiple contexts into one, and you select something from them, but not transform them completely multiple times. That's what I mean by Curie syntax, where it works for getting data, but not for transforming data too much. And yes, this is essentially inner join, like Joshmont mentioned. So again, what happens here? It happens that we select people, and for every person, we select cars into grouping. So person now has a grouping of cars. So cars that are grouped together for that person. So if you compare lines of code for this and other syntax, this is actually shorter. So when you're proficient with it, it's actually more efficient to write it in Curie syntax, queries like this. It's considered more clean. But Um, it's definitely not a mistake to write it in another syntax as well. It's your preference and it's up to you what you choose. So LINQ is definitely a powerful tool in C# for making data transformations, for curing data. And before trying to make fancy loops with fancy filtering or fancy transformations of data yourself, try to look into LINQ and see what is there already done for you. Learn to use the tools that are made for you. And expose yourself to the beauty of C#, because there's definitely many things to choose from to make your code clean, self-documenting, and neat. So let's now the questions part. Guys, please write one thing that you think you understood very well and one thing that you would like to understand a bit better, or a question. So one thing that you think you understood well and one thing that you would like to understand better. And in the meanwhile, I'll give you 2 minutes and I will go grab a drink. The class is not over. There's still a live coding part, which will also take like 20 minutes. Be right back in 1 or 2 minutes. Please write one thing down that you think you understood well and one thing down and one thing that you would like to understand better. Okay, questions. For me, everything is clear, but I have to work with join to get used to it. Judgment. It's not completely accurate, but it's simple overview to visualize what's happening. I wonder if you Kaizen are a teacher in real life. No, it's just my hobby. I am actually a hobbyist teacher. I was working as a part-time teacher, but only for a short time, as it was taking too much of my time, even more than now. Time complexity on these, it's optimal as you can get. The only complexity, the only overhead there is for converting the LINQ in a for loop. So it's actually quite optimal. And I don't think that, like, if you would just try spend a day writing some join yourself in a for loop, you would not make it faster than LINQ. Pretty sure. It's optimal. It's optimized for such cases and it uses advanced algorithms to fit the case, the need. So I think the most interesting part uh, is so in this lesson material, I made a sample set for cars, people, and car owners. And basically, all that I demonstrated with method syntax, I have also done in Curie syntax. So basically, mirrored example for demonstrations of how you do all that I did in the lesson with both Curie and method syntax. Is there a new folder? I have no idea. So, I think one of the more interesting ones for the equivalent of select many in Curie syntax. So select many is actually select twice using Curie syntax. So you see, if I want to flatten a list of cars from car owners into just a list of cars that is merged, what do? I first select owner from car owners, and then I select car from cars. And then I say that from that, I select a new owner and its car name. So this will flatten a list of cars into just car owner, like what cars does each person own, but in a single list, not in a list of lists or similar. So a flat list of cars that people own. Geostriker said that there are things way faster than LINQ. Maybe, but I don't think you would make it yourself. Like, you could, but it's not worth it, and without some extra library, I don't think you could write something better in relatively little time. It's not that much slower. There isn't that much overhead. It is slower, but it's not critically slower. It's not times. It's percent. Yeah, exactly. LINQ is for lazy programmers. Actually, also, LINQ makes code very readable as long as you don't mess it up. LINQ can be written really poorly and then the effect will be opposite. Okay, do you have this project code? I surely do, and I'll give you links to slides and to the project. So here you go, links to the slides, and I'll push the code to the branch. So lesson material for Curie and method LINQ syntax. So let's go here and let's open the branch. I did not want that. It's everything. Yes. Essentially, why am I back? These are the demos. It's, I think, a good snippet for quick reference, like a good cheat sheet. This demo page is, this demo folder. I separated, like you can see, every demo for method and Curie, and then we have select demo. So you can debug this if you want, you can play around with this, you can comment stuff that you don't want to run, and so on. So some lots of room to play around this stuff. Yeah, demos are useful. And each method here has a few cases. For example, for select, I made 3 select demos, and so on. Well, of course, I base homework on the material we went through because it's convenient and makes sense that I do it because it's still fresh in my memory as well. Okay, should I show something else? Select. Well, also sometimes, you want to just maybe select twice, So this one is an interesting. Basically what this does is, so you should read it from here, actually. You start from here and you say, okay, so I select cars for every car owner, so this is here, and then I take the first cars of a car owner, and then I select cars from the first car owner cars, and then I select car names of first car owner. So this right here, when you start mixing method syntax with Curie syntax, it might start being not so nice. It might start getting in the way of readability. So it's not always the best to use Curie syntax if you need methods like first or default or similar, because you cannot mix it that easily. Okay. What else? Well, it's just getting used to, and I recommend practicing both things. But in homework, I'll only required to write either in either style or both styles if you want. But the homework will need to be just done, and that's all. And for homework, since Mikhail wanted something more complex, something more realistic, um, I came up with a task. I didn't write it down yet, but I came with it. I still need to fully formulate it to be given as a normal homework, but the essence of it sounds like this: that you have basically shops, and each shop has a dress, and uh, then there is transactions that happen at a certain place, and then there is a receipt, uh, which was so transactions that have a date that happen at a certain time at a certain place, and uh, and a certain amount of money was paid. So you will need to make all sorts of statistics for what time is the most beneficial time, what is the peak time, how much money was made at which time, which city has the biggest traffic of transactions, which city has biggest average of transaction. And you see, I already set a whole lot of queries, a whole lot of cases, and there won't be any UI this time. Zero UI. And what I mean is that you'll have to call a console using arguments. Um, for example, uh, this is also what I wanted to show today. I don't normally do this, but I think it's there. Yes. For example, Kaizenau. If I save this and if I run the program, and if I say and if I put the breakpoint, you see that you have my name here, right? So I can debug console application by passing arguments to it. So your homework will be to actually do this instead of using a UI and typing something, selecting options. It'll be work with command line and working with your application through command line by passing arguments and creating reports for data based on those arguments. Right. So I also want to show some neat trick, and this might be also useful to those, the Geostriker maybe. Let me know if you know this trick, because I didn't know like a month ago. My colleague showed me. So we go to bin, for example. 4, nope. This is the one, yes. So let me know if you know. So if I type CMD in search window, it will open a console that is opened in the path that I typed CMD. And now, for example, I can call um, um, come on. Why doesn't it let me paste? Great stuff. Bootcamp.chapter.exe. And if I say, for example, let's say Joshmond. So if I do this, it will open my console application with arguments as Joshmond. So if we go up, you can see Joshmond was printed there. And method syntax, as you can see, like this is actually still a console window. It's not the same window as your application. So it basically prints it, works with the console window that you called it from. It's quite neat. So you can pass multiple parameters here, no commas needed. So I can run this again. Well, I didn't print anything. I can make it that it prints all the arguments. So environment line args print. Not quite. Okay, like this, and not needed, and like this. Okay, so if I rebuild this, and if I go here and just run this again, it's very annoying that I cannot run it by pasting the name. I don't know why. So let's try something like this, something like this, something like this, something like this, like this. ISNL in the end. Boom. And you can see it printed all of the arguments that I passed. So no commas are needed here, as like it separates it by a space. Yeah, by a space or so yes, for next homework, this will actually be a continuation of homework. If we look at our schedule, we're gonna learn quite some useful stuff, which is attributes. I will actually put this after. No, I won't put this after. Okay, so we'll learn attributes in the next lesson, and the lesson after that we'll learn JSON XML. So very useful stuff. And those two next lessons will be related to this lesson homework. Joe Striker, I tried that and it didn't work. Like I said, my mouse is broken a bit, so it might be due to that. But I did try to paste it by Control C and then right clicking, and it didn't work, and it still doesn't work. I'm right clicking right now, so I don't know what's wrong. It works in my work computer with my work mouse, but not here. I don't know. Ref is not a code smell. It has certain use cases. Actually, wait. I don't know any use cases for ref, I think. I just taught it because it's useful for optimization reasons. Like there's literally no practical reason. If you don't care, you don't use it. But for performance, if you really know what you're doing, ref is useful. So it's not a code smell. Well, it's a code smell, but it means that it might be useful in some cases. Just if you use it, you shouldn't abuse it. Yes. So I just mentioned it in there. Out is only practical in try-parse pattern as far as I'm concerned, and in uh, and in is very specific version of ref for the same reasons you don't really use it. Uh, out is powerful in try-parse, definitely. It's not the code smell. Yeah. Ref is quite used in .NET framework, to be honest. If you look at the decompiled code, you'll see ref structs that are passed by ref, big structs that are passed by ref. For example, the whole task-based programming, the state machine was a struct, and they used ref to pass it around. So you cannot dismiss the power of it. Okay. Do you have any questions before we end this lesson? And I'm sorry if the lesson was too short. There's also no Kahoot today because I really ran out of time. Any questions, guys? Yes. So Roloff said he's concerned that I removed lessons, expressions, removed tuples, removed expression trees to be precise have been removed. Yes, I put those all at the end, even though I removed them, deeming them as extra, as something that is very niche and you won't be using much. I still want to demonstrate it in the last lesson, along with reflection and unsafe code. Just to just familiarize you a bit, to just let you be aware that stuff like this exists. But I won't make a homework out of it. It's just an introductory lesson. Classes are always at the same time, and there's sometimes a delay, 30, 60 minutes delay at most. So it's always in between 9 and 10 p.m. GMT plus 2, and it takes 1 or 2 hours. Um, yeah. Striker, you asked about deconstruction, and deconstruction is basically uh, when you get something or create something, you can just uh, get the bits that you need. Yes, it's commonly used with tuples. But yeah, it exists in C Sharp. If I am correct, I believe you need to mark. Oh, if it works like JavaScript or not. I don't know how it works in JavaScript, so I cannot say. I don't really use it, so I wouldn't be able to say it right away. I literally never used it. Not very practical to me personally. Yeah, 2 weeks and the chapter's over. Okay, so if no more questions, that'll be it for today. Deconstructors are a different thing. It's not the same as deconstruction. Deconstruction is just ripping apart object structure, and deconstructor is something that is disposing memory, freeing up memory, the opposite of object creation. So it's only for C C, and similar languages, more low-level languages. In C# we have something like finalizer, which is similar to. Yes, that's C thing, and C, I think, as well. It's not C# thing. We have finalizers in C#. Okay. We'll see. In C# we just use side disposable pattern. But anyways, link that in BC discussion. That is it for this lesson. Thank you all for your time, for attention, and see you on Saturday. Bye bye.